Hey guys, welcome back to my channel. Thank you so much for all the support. Thank you for always watching. Thank you for always commenting. And thanks to those who have told someone about the channel and have them subscribe and watching my videos too. For those who are joining for the first time, my name is KAYIE'S Harrison and thank you for joining as well. Today we will be looking at fractions. We're continuing with fractions and we will be learning to change a mixed number to an improper fraction. So remember, in our last lesson I spoke to you about the different types of fractions. We learned about a proper fraction where the numerator is smaller than the denominator. We learned about an improper fraction or a fraction greater than 1 where the numerator is bigger than the denominator, and we also learned about mixed numbers where we have a whole number along with a fraction. Now today we will be changing mixed number, that is the one with the whole number and a fraction. We're going to change it to a fraction greater than 1 or to what we call an improper fraction. There are two ways in which we can do this, and I am going to show you both. We're going to first look at one way with a diagram, and then we're going to look at it without the diagram. So let's go. On the board I have 2 and 2/3. That is a mixed number. The 2 here is my whole number and this 2/3 is my fraction. The 2 is the numerator, the 3 is the denominator. Now, remember, the denominator tells us how many parts the whole is divided into. We know that the whole here is divided into 3 parts. We also know that we have 2 complete wholes. So I'm going to draw those. I'm using rectangles to represent that. So I have 2 wholes, and each whole is going to be divided in 3 parts because my denominator is 3. So 1, 2, 3. And remember, fractions name equal parts of a whole. So I am pretending that these are equal. Remember, they are not drawn to scale. I'm not measuring them. And this is also divided into 3 equal parts. Now these are my 2 wholes. My 2 wholes. However, I have a fraction which is 2/3. It simply means I have to draw another whole that I will be using to represent that fraction. Again, it's divided into 3 equal parts because the denominator is 3. Now, can you tell me, based on our last lesson, how many parts do I need to shade? If you said 2, you are correct because my numerator is 2. And remember, the numerator tells us how many parts of the whole is being considered or how many parts are taken out. So in this case, it's 2. So I'm shading 2 parts. So it means that I have 1 whole, 2 whole, and then 2/3. Because this is 1, 2, 3. That's my denominator. 1, 2 parts shaded. That's my numerator. But how do I use this to help me to represent my mixed number as a fraction greater than 1 or as an improper fraction? All I need to do now, boys and girls, is count. My denominator will still be 3. Denominator is going to remain the same. How many parts am I considering out of the total here? It's 1, 2, 3, so that has 3 out of 3. 4, 5, 6, that's 3 more out of 3, and then 1, 2, that's 2 more out of 3. So 3 plus 3, that's 6, and 6 plus 2, that is 8. So it means that my numerator is 8. my improper fraction, or my fraction greater than 1 whole, is 8/3. So all we do, we count the amount of shaded parts, and that's our numerator, and then each figure is divided into 3 parts. So it means that my denominator is going to be 3. Let's look at another one, because I don't expect you to get it on the first go. So this time we have 3 4/5. How many holes do we have? We have 3 holes. So I'm going to draw my 3 shapes to represent the hole. And I still have 4/5, so I need to draw another shape to represent that part of the fraction. Now, my denominator is 5, so it is telling me how many parts each of my whole is divided in. So it means that I'm going to divide each of these into 5 equal parts. 5 equal parts. 1, 2, 3, 5 equal parts. And 5 equal parts. Now, my 3 holes, which are these 3, I am going to shade everything inside because they are whole. I'm considering every single part of them. So I'm shading everything in the hole. Alright, and then the one that is representing the 4/5, how many parts do you think I'm going to shade? 4 parts. Good job. So 1, 2, 3, 4. So now this is 1 whole, 2 whole, 3 wholes, and then this is the fraction, which is representing 4/5. Now, how am I going to figure out my fraction greater than 1 or my improper fraction? Again, each shape is divided into 5 parts. So my denominator is 5. And then all I'm simply going to do is count the parts that are shaded, and that is going to be my numerator. So this is 5, this is 5, this is 5. If you can count by 5, it makes it easy. 5, 10, 15. Then we say 16, 17, 18, 19. Or if you are unable to count by 5, simply count them one by one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So 19 parts out of the 5 is being considered. Now, our improper fraction, or fraction greater than 1, that is equal to 3 4/5, is 19/5. We can do it without using a diagram. So we're going to look at that now. So here I have my 3 2/3. So we need to take some simple steps. Step 1, we have to multiply the denominator and the whole number. We multiply those. And then we add whatever answer we get to the 2, which is the numerator. We call it all around the world. So we're moving from the 3 to the 3 and then to the 2. So we're going all around the world. If you can remember that, you should have no problem with changing your mixed numbers to fractions greater than 1 or improper fractions. So again, we multiply the denominator by the whole number, and then whatever we get when we multiply them, we add that to the numerator. So 3 times 3. Remember, if you don't know what is 3 times 3, it's okay. Skip count by 3. So 3, 6, 9. It means that 3 times 3 equals to 9. So I'm putting my 9 up here, and then I'm going to add that 9 to the 2. 9 plus 2, that makes 11. So it is 11 thirds. So 3 and 2/3 changed to an improper fraction, or a fraction greater than 1, is 11 thirds. Let's try another one. 4 and 3/5. Again, we're going all around the world. So we're multiplying the denominator times the whole number, and whatever we get, we add it to the 3. So 5 times 4, again, if we don't know, skip count. 5, 10, 15, 20. So 5 times 4, that's 20. I'm writing it there, and then I'm adding 20 plus 3, that's 23, and our denominator remains the same, so it's 23/5. Now you can write it like an equation, but I prefer to do it like this, as I am going all around the world, and it helps me to keep everything in one place and not forget anything. But for example, you could say 3 and 2/3 equals, and you write 3 times 3 plus 2 all over 3, because you're multiplying 3 times 3, and then you're adding the 2. And you go all over 3 because your denominator will remain 3. So 3 times 3, that would be 9, and the 9 plus 2, that would be 11, and the denominator stays the same. Again, you could go 4 and 3/5 equals, and you go for 5 times 4 plus 3, and it goes all over 5. You multiply 5 times 4, and you get 20, and then you add the 20 plus the 3, you get your 23, and your denominator remains the same. Pretty simple, boys and girls. Just remember, you can use your diagram if you're not comfortable multiplying, or if you don't know the times table and you prefer to just draw some quick diagrams, or you can simply multiply all around the world. Now, I am going to give you one to try on your own. 6 and 2/7. I want you to try both methods. You're trying this one on your own. I want you to try both methods and see which one you're more comfortable with. Are you more comfortable drawing the diagrams, or are you more comfortable working it out? Pause the video. Go ahead, pause it, and try this one for me. 6 and 2/7. Change it to an improper fraction or a fraction greater than 1 whole. Let's go. Pause that video and come back. All right, so here I have my 6 wholes, and each whole needs to be divided into how many parts? 7 parts, because the denominator is 7. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Remember, it's not going to be perfect because I'm drawing them. 4, 5, 6. It's not going to be perfect. I'm not measuring. 1, 2, 3, 4, 5, 6. This is kind of long because our shapes are being cut into 7 parts. And it's 6 shapes so far. So there we have our 6 shapes. But remember, we have this 2/7. So we have to draw an extra one to represent our 2/7. So let's go. 2, 3, 4, 5, 6, 7. Now we need to shade all the holes. So we're shading all the holes. 6 of them. And 2 out of 7 parts to shade over here. So 1 part, 2 parts. So now everything is shaded that needs to be shaded. All we need to do is count. The only thing is we have a lot of counting to do if we don't know our times table. So this is 7 plus 7 plus 7 plus 7 plus 7 plus 7. How many 7s? 6 of them. So 6 sets of 7, that's going to give us 42. And then we have 2 more. So 42 plus 2, that would be 44. It simply means that our answer would be 44 sevenths. If you don't know that 7 sets of 6 or 6 sets of 7 is 42, then you'd have to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 until you count all of these. And then remember, whatever you get, it goes over the denominator, which is 7. Pretty simple, boys and girls. This way is a bit longer, but if you don't know your tables, it's an easy way to solve problems like these. Now, the next time we do math, we will be going the opposite direction. So we will be changing a fraction greater than 1 to a mixed number. I'll see you in our next video. Remember to like, share, leave a comment, and subscribe. And guys, don't forget that you can tell me, especially on a Friday, what words you want me to talk about. What commonly confused words do you want? So hit me up in the comment section on Facebook, on WhatsApp. Let me know which commonly confused words you would like to see. And guess what? My son has a channel with all the fun stuff. So if you want to see the challenges between my son and I, then check out Cam Brian 09. All the fun videos are on that channel. See you soon. Bye.